Now I'm telling you I want to close this breaker completely in the service position, meaning service, meaning in what position? In the service position, beautiful, very nice. To close the breaker in the service position means that I want to take the load on this bus bar and bring it here to the line, or this could be the source of the load coming to me here on the line, and I want to input it to the bus bar. This is what service position means. In this case, engineer, you need to make sure of one thing. Either Q1 is closed or Q2 is closed, meaning one of these two is completely closed, or both could be closed, it's not an issue. But I'm telling you, either this one is closed or that one is closed. The important thing is that there is a connection with the bus above or the bus below it, all right? As for the other disconnector, it should also be closed. Now let's say something. There's a rule I always used in explanations with the young engineers. Even within our company, to make the topic a bit easier for them. All right, good. What does this topic tell you? I came up with a very simple rule that I tell you about. You have disconnector switches, circuit breakers, and what else? You have earth switches. All right? Consider this rule, I call it Rashad's law. All right? You have the disconnector switch, its interlocking must look at the breakers and look at the earth switches. Breakers, and look at the earth. While the circuit breaker only looks at the disconnector switch, and the disconnector switch only looks at whom? At the disconnector switch. So the disconnector's locking conditions must verify the state of the breaker and the state of the grounds, while the breaker's locking conditions only verify the state of the disconnector, and the disc switch only verifies the state of the disconnector. Great, guys. Very good. Okay. What did he say? Now I'm talking about the breaker. The breaker says, what do I want in my breaker now? Okay, great. No problem. In the breaker, because we agreed in the test mode or test position, Q1 is open, Q2 is open, Q9 is open, so the breaker is isolated before and after, meaning it is neither connected to the line nor to the bus. Okay, I want to close a breaker in the service position, so I need to check the disconnectors. One of the disconnectors before it is closed, and one of the disconnectors after it is closed. All right, someone might get a shock. Be careful in case the ground is closed or something. Now, I'll tell you something important. To close a breaker, who did you look at? The disconnectors. Now, you just told me you want to close this breaker. So I'll tell you, go ahead and close Q1. When you come to close Q1, you'll find there's interlocking. You'll find that this interlocking checks on whom? It checks on the grounds. So when the breaker looks at the disconnector, which is actually looking at the R switch, it's as if the breaker implicitly also looks at whom? It looks at the R switch. All right, so now, as we agreed to know the breaker, Q1 or Q2 must be closed. And Q9 must be what? It must be closed. All right, that's great. So these must be closed first. Why must these be closed first? Because if you close a breaker, none of these will work to close, as they are not designed to close or open for loads. Only the breaker closes and opens for what? For loads. So we close Q1, for example, and Q9, then finally, who do we close? We close the breaker. All right, now to close the breaker. Now, to the right of this breaker, there is voltage, and to the left, what is there? To the left, there is voltage, right? So it could be live here and dead here, or it could be live here and dead here, or both could be what? Both could be live. That's why when we come to the breaker, we must have something called synchronization. Also, it's nice that you have on your line here something called, which is essentially it's essentially that you have something called. All right, that's its part. Then you find what? And it's protected by, all right, very good. So you have here what? Your part, all right? And here you have the other components that we refer to as. Then all these wires go down, down, down until they reach where? The LCC panel, and they also enter into what? The MCB. This is what we call our LCC panel. Then from the LCC, it gets distributed to different circuits. All right, very good. Now, as a circuit breaker, I want to close and perform synchronization. Okay, and once Fadi tells me, let's assume that Q1 and Q2 are both closed, it is considered a normal situation with no danger. Yes, of course, once Q1 and Q2 are both closed, you don't have any problem. There are no issues at all. But wait a bit to understand that for Q1 and Q2 to close together, you need to close a coupler or sectioning with a distant coupler. So wait a bit. All right, I'm telling you now, whether this one is closed or that one is closed or both are closed, it doesn't matter to me. The important thing is that it's on and the line disconnector is closed. After that, before closing the breaker, I need to ensure there is synchronization between the voltage before and the voltage after the breaker. So I have a voltage transformer here on the line. All the feeders you have must have a voltage transformer on the line. And the bus bars also have a voltage transformer on them as well.